I'm seeing how my explanations go. So you guys have to look super engaged in this. All the hands.
Undefined and zero defined. Right?
Jack might even be able to explain that for us. Undefined and zero?
When you're trying to solve for x like we did before, and
Like we did before?
in class,
In what types of problems? What's our unit called?
algebraic fraction.
Okay, so when you're using an algebraic fraction and you want to look at the denominator, what? Tell us about the zeros and undefineds.
If it's, let's say, x minus 3, and you need to find out what 0 would be, you see what you can take out of it. For example, the minus 3, so you can add 3 to the other side. So x will equal to 3, so that means that x cannot equal 3.
True.
Because then this fraction would be 0.
Yes, the denominator of the fraction would be 0. Can someone say that in another way? No? Does anyone else know what we're talking about? Remember when we said which values are excluded for x? There you go.
When you say like you make the denominator 0,
Mm-hmm.
is that what it is?
Yeah.
Because like in the textbook it said like say when it's 0 or undefined, and I was like,
Same thing. And that's what your original question was. When is it 0 or undefined? And it's when the denominator equals 0, and you would get that error in your calculator. So you need to set the denominator equal to 0 so that you can find out when it would be undefined. So like if we had 1 over x plus 3, then you would set the denominator equal to 0 to find out when it wouldn't work. So x in this case would equal negative 3. So in the case of that algebraic fraction, you could say x cannot equal negative 3.
that's what you're testing.
It's just a good idea for you guys to know. The focus of this test is for you guys to feel comfortable with factorizing and simplifying. So that's something that we'll continue to work on, but not something that's tested today. Yes?
So you will test the minus of fraction.
Yes, absolutely.
We do too.
Yeah, so let's look at the homework. And you guys can come up with some questions that you want to ask before you take this. Yeah? I think it was 2A or something like that
2b is
on page 350. So that's 2B, and it says 6x plus 3 over 2x minus 3. Divided, I was like, but that's not the whole thing. Divided by 3x squared minus 12x minus 15 over 2x squared minus x minus 3. Who did this problem?
Wait, where is it?
It's 2b from the OneNote. Okay, so it's up here. This glorious problem.
Oh, that page. Okay.
So in 16D in the OneNote. Who did that one? Yeah? Did you get a final answer? Okay, pull it up. Yeah. Okay. I see one more step that you could have done. Check out your denominator. Yeah. If you didn't do this problem already, then try it right now.
Oh wait, I did do it.
It might be. there you go. It might be the answer. We'll see if other people have the same one. You did it also?
I did do it, yeah.
Great. You want to do it for us?
Okay.
Here. Do you want to sit over here?
No.
Okay.
So, okay. First what I did is I flipped the second fractions and then got 6x plus 3.
While you're writing that, can someone tell me why she flipped the second fraction? Jack.
When you divide something, you flip this side on the right, and then you multiply.
So you take the reciprocal of the second one and multiply that. All right. We all agree so far? Yeah?
Okay, then I factorize the second fraction, I guess, and top to the bottom.
Yep.
And
And you don't need to do the full box for us. You can just tell us what you got.
okay. So how I did this.
You can still write the first fraction as is, right?
Yeah. Well, you can also factorize stuff out of that.
We'll
Do
get
you want me
there.
to do that now or like?
You can do it in whatever order you want to, whatever makes the most sense for you, and we'll just clarify it along the way.
Okay.
I got excited. A fun fact for you, if you flip my pen over, it becomes an eraser.
Oh, okay.
Yeah. Are you on the same page so far with yours? Yeah.
Okay. So
Are we all good right now? Does anyone have any questions about how she got that far? Carolina, you good? Thomas? Yeah?
do it right?
Yeah.
Okay.
What's up?
X minus 5.
You got x minus 5. Can you go back to the previous step? Oh, it might
It
be
is
minus
12.
5 because it's a negative 15, which means one of those two terms has to be a negative. So do we all agree that it's a negative 5? Ines, do you understand why it has to?
Yeah.
Okay. So you can just flip it over. There we go.
That's a lot easier. Okay.
I know. It's great.
Yeah. You can cancel out the like these two
Okay.
because they're multiplied.
Right. So even though they're not actually on the same line yet, because it's a multiplication sign, you can still cancel it out.
So okay, then what is it doing that?
It's very sensitive to hands.
Okay. And then to multiply 6x plus 3 by what?
Yes.
Don't you have to do that, like, because then they have the same denominator?
Well, we're not adding, so they don't need to have the same
Oh.
denominator.
Oh, okay, sorry. Wait.
Max, fill us in. What do we do?
Well, to factorize 6x plus 3, it would be 3 and parentheses 2x plus 1.
So we factorized out a 3 from that first term, the 6x plus 3. And then you still have that x plus 1 in the numerator. And now you can write it all on the same line.
Oh. So now I can like write the other stuff.
Right, now you can just fill the rest in.
Okay, then 2x. Wait, that's gone.
Yes. Now, that one. anything that can be factorized still? Jack,
3 from the bottom, 3x plus 3.
totally. I like all these arrows. What else?
More arrows. Yay.
What else can you kids
Cancel
love?
out the x plus 1 and the other x plus 1.
And
3.
and the threes. This 3 over 3 gives us what?
And then we have 2x plus 0. Yes, it is. Over x minus 5.
Yeah.
Are we done?
Are we done? Thomas, what do you think?
It's good.
It's good.
Yeah.
Thomas says yes.
Look how long it
You were very productive.
especially with your eraser.
Yes, definitely. Okay, what else? Yeah.
You would be able to describe 2x.
You would not be able to because there's nothing to multiply it with. So you don't have anything to expand it to. All right, other questions?
Are the ones where it's like x over x minus 2?
No.
X 3 over x.
Nope. I was telling Jack this morning, that's just to see how you did with those. Do you want to see how one of those goes?
Yeah.
So let's look at this one. Who got this one? F.
Oh, f. Oh, God.
Who looked at that and was like, no.
I tried it and then I was like, I think I'm doing everything wrong, and then I just like left it.
Well, what do we do first? Get scared? Samantha.
Don't you just add the top? The numerator?
So we're going to do something with the numerator first.
Yeah.
Okay. What if we just get rid of that second fraction situation? Just to make ourselves feel a little better. Right?
Oh, and that's
Thomas, what do you think?
When we put a 1 under the 9 and
Okay.
try to make the, well, just take the whole bottom off.
Just take it away? You're like, nope, gone.
And then you put the denominator as the same.
Okay. I'm going to do something. And then we're going to go to what you want to do. Because yours is really important, but I just want to do one step first. Here's my arrow. So we have x squared over 2 minus x plus 9 over 1. I'm going to put all of this in brackets because I know I need to work with that still. And then I'm going to say times 1 over x minus 3.
3.
Why?
Oh.
Huh? That was you?
Yeah.
Okay, so let's say I had 1/2 and I wanted to divide it into 4 parts. If you divide 1/2 into 4 parts, what is the final answer? What is 1/4 of 1/2? An eighth. So what we did for that one was we said 1/2 times 1/4 equals 1/8, which is the same thing we just did. So we took this denominator and we just moved it over and put a 1 over it. So now it looks similar to what we were doing before. But don't get me wrong, it's still kind of scary because we have that 9 over 1. But that's pretty easy to fix, isn't it? Selma, what do we do for that one? Yeah. So we want to make the same denominator inside the bracket so we can multiply all of those out.
Times 2 minus x.
Absolutely. And in the numerator, because whatever we do in the denominator, we also have to do in the numerator. So we'll have 2 minus x down here, and 2 minus x up here. Then we'll do our next fancy arrow. We'll have x squared plus 9 over 2 minus x times 1 over x minus 3.
Are you allowed to cancel that?
No, because it's an addition.
Right. So we still have addition over here. And we still have to do some expanding. So what do we have to do to that first term? This piece right over here.
Multiply by 9 over 2 minus x.
Distribute. So we'll have what, Jack?
X squared plus 18x minus 9x. Sorry, plus 18
There we go.
minus 9.
Minus 9x. And since this is times 1, I'm just going to say that we know something times 1 is itself, so we don't need to keep rewriting the times 1. So then in the denominator, we have 2 minus x and x minus 3. Carolina, how do we factorize the numerator? Want me to rewrite it? Okay. Definitely. Let me do this just to help the visualization. I like to write them in descending order because then it looks the same as always. So we want two terms that multiply to 18 and add to negative 9. Carolina's thinking about it. It's okay. What are the factors of 18? 9 and 2. Do those add to negative 9? No. There's 1 and 18. Do those add to negative 9? There's 6 and 3. Yeah. So how are they going to go? If I put a 6 here and a 3 here, I need them to be positive or negative? Okay. Yeah, the negatives multiply to a positive 18, and they stay negative to give us that negative 9x. Thomas, does that make sense?
Yeah, but if you go back,
Yep.
back quickly.
Yep.
Yeah, when you multiply the 1 times 2x, and then on the other side is 2 minus x.
Yep.
So you wouldn't combine those or add those.
So
Just
because
use one.
they had the same denominator, which is why we were able to put all of the numerator together.
So you only need one.
Right. So now what do we do, Thomas?
You could cancel.
What can we cancel?
X minus 3.
Okay, and what are we left with?
X minus 6 over 2 minus x.
Over 2 minus x. And can we do anything else? Here's something that people are often tempted to do. Does that work? Who's done this before? Everybody? Yeah.
You can't do that because like the topper is like a bowl, like you can't just cancel out the 6 on the top because it's attached to an x.
Yeah, absolutely. They're attached to each other. They're in those imaginary parentheses. Look, the x minus 6 and the 2 minus x were both in parentheses